Hello everybody, I am Ben from Team Panic, and this in front of me is my attempt at the 9-hour beetle challenge. Now if you've been on the channel for a little while, this thing should be familiar. We've done a few bits and pieces on this particular beetle through the last kind of year or so, and it houses itself around this thing at the back here, which is an EDF, or an electric ducted fan. Basically an electric jet engine powered by a brushless motor, which is this guy all the way out the back here. Now, all the time that I've been attempting to use this, I've been meaning to actually test its thrust characteristics and test just how well this thing actually works and what affects its thrust. So basically, because it is just a fan spinning inside a tube, certain things will affect how much thrust you get through, and that is the amount of air coming in, the amount of air going back out again, and also a thing called a thrust tube, because apparently the air that comes out of the EDF kind of swirls quite a lot as it comes out, and if you put a thrust tube on the back of that, it kind of pushes it and makes it nice and straight and flat as a vector, which means you get more thrust out of it. However, the thrust tubes that are recommended for an EDF are 4 times the length of the EDF, which means that for this guy, the thrust tube is like all the way back out here, which is, not achievable inside a combat robot. So today we are going to take this EDF off of this beetle. We're going to bolt it into a new housing, which I have done up, which at the moment there is still support material in there, but there will be bolts that go through here. I'm going to stand it on the scale next to me, and we are going to test it. And first of all, we're going to test it plain, and then we're going to start bolting on some inlets and some thrust tubes, and we're going to see how much thrust we get out of this and whether or not thrust tubes are actually that important. So one of the big things I have seen is that thrust tubes are really helpful when you want to increase the speed, because if you decrease your nozzle size at the output of the thrust tube, you can increase the speed of the air coming out, which is awesome if you're flying a tiny little plane that is way less weight than this thrust can output, because that means that you can fly really fast, but it obviously, when every time there's a speed, torque, thrust thing, there's a trade-off. So if you fly really fast, you have less thrust. So for this guy, well, what we really want is as much thrust as possible and all of it going in the right direction. So yeah, I'm not sure if these thrust tubes are actually going to do anything for us, but let's find out. And there we go, the little test platform is now done and dusted. And next to that are these things. So all of these are printed bits for the testing for today. So the stuff in the middle, these are inlet intakes, which are supposed to bolt in under here. However, you should notice quite quickly that there is a little bit of a problem with that. So I didn't measure the bolts that I had before I actually printed these inlets, and I seem to have messed it up. So I'm either going to stand these on blocks or just ignore the inlets for the moment anyway. These things aren't quite what I want to be testing today. They were just going to give me a little bit of a baseline, and they didn't print the best because they're kind of full of support material up in there. I'm not sure if you can see that too well. Yeah, so I'd need to redesign these to actually be better to come off the printer, because I have a feeling that all of this kind of ridgy mess down the bottom here left over from the support material is going to impact the airflow. I don't know if it's going to do good things or bad things. It's just another variable that I would have to account for, and yeah, I'm trying to minimize as many of those as I possibly can. So anyway, those aren't the big thing for today. The big thing for today is the thrust tubes. Now, this thrust tube here, the absolutely massive one, is the correct size for this EDF. It is 4 times larger than the EDF is round, and it has a taper between here and there. So this tube up here is 5% smaller than this tube down the bottom here. And that apparently gives you the best thrust output for a tube like this. You can't go 100% because you need a little bit of back pressure in the tube to make everything straighten out and flow the right way. But adding a 5% decrease in radius up the top here apparently allows that back pressure and also keeps the same speed. If I'd gone further down, the air would have come out faster with less thrust, and we need more thrust, or as much thrust as we can get out of it. So, and obviously this thing is massive and just huge, and there's no way I'm ever putting this inside a combat robot. It just would not fit. One way or another, some part of this would be hanging out the end of the robot and get hit and destroyed. So that's why we also have this guy. This is, I think, 100 mil or 120 millimeters long. It has the same profile, so it has a 5 millimeter reduction at the end here. Reduction in diameter at the end here, but it's a lot shorter. And this, I could see myself fitting inside a combat robot. So we're going to try out both of these at the moment, and we're also going to try it stock standard. I'll then have a look and see if I'm going to bother putting these inlets on or not. I really don't know at this point in time. As I said, I would need longer bolts, and I think longer bolts than I can get at my local hardware store to actually fit these in. And yeah, they do need to be reprinted to be more printer friendly. Anyway, let's get on with some testing. So we'll test the blank one first, then we're going to test the large EDF tube, thrust tube, and then we're going to print the small one and see what difference they make. Okay, so here we go. It's all wired up. We have basically the same electronics I used in the Beetle over here, and then EDF mounted up over here, and there's a battery behind that you can't see. However, this turned out to be a little bit more difficult than I first imagined it to be. Now, just as an example, I'll quickly show you. So if I sit the EDF right there in the middle, I've zeroed out the scales and then turn the EDF on. Be warned, this is going to be loud. As you can see, left to its own devices, it falls off the table. And of course, any way that I try and hold this, I add weight to the scale because I can't just kind of hold it in place. So I almost need a better system for doing this. And as you can see, as I torque, the amount that I hold this down to the scale changes. So I'm not really sure I'm going to be able to get reliable readings out of this. But if we throw the throttle up again, once again, be warned, this is going to be loud. I am getting about half a kilo of thrust out of it, which is not great. That's not what I was expecting. I was expecting like 2 kilos or so of thrust out of this thing, and I'm just not seeing it. I mean, I got the stick to about 75% there, and yeah, on the scale we got to about half a kilo of thrust. And like I said, I thought this thing was rated at 3S, which is what we're running. This is the battery pack from my Beetle. It is a 3S battery pack. I thought that this was all supposed to be running around about a kilo, maybe a kilo and a half. So we're going to have to try these guys out, and I'm just going to have to do the same thing. I'm just going to have to hold it as best as I can without really disrupting the scales too much. But the grand scheme of things, me holding it seems to add or subtract kind of 10 grams, whereas the actual fan is giving kind of 500 grams. So on the whole, it shouldn't be, I shouldn't be making too much of an impact on the final results that we get here. Okay, so I'm going to modify these because they need a hole for the wires to come out of, and then we're going to test both of those. All right, so this is the long EDF tube, thrust tube, and we're just going to turn on the actual scales again because they turn themselves off. Hold onto the test tube, and 3, 2, 1. And it is final test time, so we're going to power up the scales once again, and we are going to test the short thrust tube this time round. Okay, scales fired up, and in 3, 2, 1. Okay, and conclusions time. So there's not actually a whole lot I can really draw from all of this. Yeah, the experiment didn't quite work as well as I intended. These tubes didn't really seem to do much, but I think it might be to do with the testing methodology. I just kind of assumed that jumping this thing down on a scale was going to do what I needed to do, but if you actually look at proper thrust test rigs, they actually mount these things in such a way that they can only move in one direction, and I was not considering the fact that this could skid around on my scale here. So what I actually need to do is mount this to a sled on a line or on a piece of like aluminium extrusion, for example, mount it to a sled so that it can only travel in one direction, everything else is rigid as possible, and then either use a proper force gauge or continue using the scale here to measure how much force this thing can actually output. And I think that's kind of where I was getting this issue from, that these thrust tubes didn't really seem to make much difference. Especially like the big one and the small one seem to do about the same, and yeah, they weren't much improvement over just the EDF on its own. However, I did learn that the EDF on its own is only producing about ½ kilo of thrust, which I found quite surprising. It was supposed to be spec'd higher than that, and obviously it just goes to show you that you can never trust specs, especially not specs on cheap things that you get from China, which is a lot of where I get my electronics from. Yeah, so that's interesting, and it's kind of actually making me think that it might not be the greatest idea to jam this thing inside a beetleweight, because realistically that EDF is only putting out 1/3 of what I need to push a beetle along with. So, I mean, it's still going to add a little bit, but it's not going to add the real thrust that I was aiming for when I decided that I wanted to try and jam one of these things into a beetleweight. So yeah, I don't know about that. Also, the other thing that's just kind of I'm thinking about, I didn't actually recharge the battery between tests, and that probably would have been a really good idea. I have a feeling that it's dropped down a little bit. It's probably dropped 0.4, 0.5 of a volt, but that does make a difference. Every point of a volt you drop, you're losing RPM out of the fan at full speed, and that means that you're losing airflow out the top of the thing, which means you're losing thrust. So yeah, this experiment can definitely be done better, and it is something that I will be coming back to later on in the future. But for the moment, it has been helpful because it's shown me that this EDF is outputting a lot less thrust, about half the thrust that I thought it was going to output. So that is interesting to know. I don't think I can get 2 of those into a beetleweight though. Just space-wise, trying to fit 2 of those into a beetle is going to be interesting. So, I don't really know where to go from here. I do want to keep testing these out because I would like to try and jam them into a combat robot at some point, and maybe I can jam 1 or 2 of these into a beetle. I just have to be a very wide beetle to get that all to fit in. So, Anyway, as with everything kind of engineering-y, you learn as much from failure as you do from success. So even though this test failed dramatically, I did still learn something, and I now know for the future, whenever I need to test EDFs again, that I need to do a lot better than 4 bolts to hold the thing up and keep it from moving all over the place. So there you go. If you want to test an EDF, don't do what I've done, obviously. Build something a little bit better. Yeah, and I hope you guys enjoyed that one, and I will see you in the next video.